Okay, so we are going to look at physics problem uh, with forces. So let's say we are told that an object or a box of mass 8 kilograms, and we are told that it is accelerated with 2 meters per second to the left, right? We are told that it is accelerated to the left. That acceleration is 2 meters per second to the left, right? So we are told that there is a force that is applied in that direction, in the left side or to the left side. That applied force, we are told it is 20 newtons. That is the applied force. So we all know once we apply force on an object, and if it is on a surface, there's going to be a frictional force or a friction force that is experienced by the object. So, and the friction force or the frictional force, it is in the opposite direction of the applied force. So, going to denote it as the small letter F, right? So, the first question, let's say number A. Let's say we must determine the frictional force F, right? So we must determine the frictional force F. How we do that is we have to use Newton's second law. So this is how it says. It says the net force that is applied, the net force on this object, that is all the forces, the resultant forces on this object, that is the net force on this object, it is equals to mass times the acceleration that is from this object, right? So basically what you have to do is to make sure that the left hand side, which is the net force, it is written in terms of all the forces that are experienced by this object. So we all know, or we have seen, that we have the applied force, the first one, that is the applied force, and also we have the frictional force, right? And the other thing, again, we do have the normal force and the gravitational force, but these two cancel each other. So they cancel each other because they are the same, and they are both in the opposite directions. So since they are the same values, and they are in the opposite directions, which means they have different signs, so they will minus each other and cancel each other. So in this case, we will only focus on these two forces that are shown on this diagram. So the first one, let's see, it is going to be the force applied. I'll denote that as force FA, which is the force applied. We add it with the frictional force, right? So these are all the forces that are acting on this object. Then it is equals to the mass of that object times the acceleration that the object is accelerating with, right? So the applied force, we are told it was 20 newtons. Then we are looking for this frictional force. And the mass of the object, we were told it was 8 kilograms, right? And then we multiply it with the acceleration of this object, which is 2 meters per second, right? So if we solve for F, this is just basic mathematics. We just do this times this, 8 times 2, it is going to be 16. Then we minus by this 20. It's going to be 20. Then we will say frictional force is equals to minus 4, right? So let me just write it here. It is equals to 4 newtons. Now this is the tricky part. We have to make sure that we understand this part, because in order for us to determine the direction of this frictional force, we have to go back to the diagram and to see, or to evaluate in which direction it was going. So we were told that the acceleration of this object was to the left, which is in this direction, right? So if we choose the left-hand side to be positive, if we choose anything that is going to the left-hand side to be positive, and we end up with an answer that is a negative number, which means it is going in the opposite direction of the acceleration. What does that mean? It means that this frictional force, it is in the opposite direction of that acceleration. So the acceleration was going to the left. Now it means the frictional force is going to the right. And that's how we solve and determine the frictional force on an object that is moving in the straight line direction.